We recently took practice 1 multiple choice with the graphing calculator, and this video is going to include some selected solutions. In fact, I'll probably make several videos with solutions, so we'll just call this part 1. Let's get right into it. So in problem 41, we are asked, which of the following is an equation of the curve that intersects every curve of the family y equals log x plus 2 at right angles? So we're going to find the equation of the curve that intersects every curve of the family y equals log x plus 2 at right angles. So for this problem, you really don't need the graphing calculator, although for many of these, the graphing calculator is required. What I'm simply going to do is I'm going to find the derivative of this thing, which is our slope machine, right? It's our formula for the slopes of tangents to this function y equals log x plus 2. The derivative here is 1 over x. So these are the tangents. We are looking for the lines that intersect at right angles. Those are called the normal lines, and they are perpendicular to the tangent. So what I need is the opposite reciprocal for my slope. So that would be negative x. And then we are looking for the equation of the curve that intersects every curve. So this is the slope. To get backwards to the original function, we have to do the antiderivative. And so from there, what I'm going to do is the antiderivative of negative x, which is negative 1/2 x squared. And that will be the equation for the function. And so as you can see here, that's letter D. So just to clarify what we did, we start by finding the formula for the derivative because that gives us the slopes of the tangents. Since we need the normal lines, we do the opposite reciprocal, and then we do the antiderivative there to get the formula. And maybe a better notation here, rather than writing m, would have been to write another dy over dx, like say dy2 over dx. And that's a subscript 2. That means this would be y2 equals. I'm letting you know that that y is different than the original function up here for y. So we find the derivative, we do the opposite reciprocal, we take the antiderivative, we get y equals negative 1/2 x squared. Okay, let's move on to the next one. A particle moves along the y-axis so that at any time t greater than 0, greater than or equal to 0, its velocity is given by v of t equals 2 sine of t squared minus t minus 1. The position of the particle at time 4 is 4 at time t equals 0. What is the position when the velocity is first equal to 0? So we got a couple things going on here. First of all, we need to find out when this thing is first equal to 0. And then we're going to do an accumulation from 0 to that point. So we'll have to do a definite integral, and we're going to use our graphing calculator to achieve this for us. The first thing I'm going to do is I'm going to graph the velocity so I can see where it equals 0. So what I did here is I typed in this function in y1. I used x as the variable, so I typed in 2 sine of parentheses x squared minus x parentheses minus 1, and then I graphed it. I changed the window so I could see, I went from 0 to 3 on the x-axis and negative 1 to 1 on the y-axis, and I wanted to locate this first place where the velocity equals 0. And I used the Calc menu and number 2, which is 0, and I answered the questions, and it popped up with approximately 1.3795. And that's the place where it equals 0. Now, that's not our answer. That's just where we want to end our accumulation. Now, to figure out the position at that time, we have to start with our initial condition, which is 4 at time t equals 0. And so I'm going to basically do 4 plus any accumulated change. And that goes from 0 to 1.3795 of v of t dt. And we can type that thing in on our calculator too. In fact, I already have this function typed in at y1, so I'm going to use my y-vars, and I'm just going to enter it this way. So because I have the old calculator, you'll see, I'll show you a picture here. I'm going to do fn int. I'm going to put y1. I find that in the vars menu. My variable is going to be x, and then my numbers are 0 and 1.3795. And I'll calculate that. I'll take a picture so you can see what I typed in, and then we'll choose our choice. And so as you can see, I typed that in. I even included the plus 4 in front. So I did the entire calculation. I did 4 plus the fn int with my function that's already entered at y1 from 0 to 1.3795, and my value came out to be 2.46617 and so on. And as you can see, that is letter D, which is the correct choice here. So we have 2 jobs. We did those both on the calculator. The first is to find the first place where this function crosses the x-axis. And since it says t is greater than or equal to 0, we're not worried about any place to the left of the y-axis. So moving to the right from 0, the first place that it hits the x-axis is 1.3795. Once I have that value, I have to make an accumulation function which adds on the accumulated change from the initial y value of 4. So at 0, we're equal to 4, and then we've added on some extra change. Actually, we ended up subtracting because this number 2.466 is smaller than 4. But we add on that accumulated change, and that gives us our position of the particle the first time this thing equals 0. All right, let's check out another problem. This third one will be the last one we do in this video. For number 35, we're told that the position of the particle moving along a line is given by s of t equals 2t cubed minus 27t squared plus 84t plus 11 for t is greater than or equal to 0. For what value of t is the speed of the particle decreasing? So 2 things we're going to be interested in. We're interested in speed, and we want to know when it's decreasing. So the first thing we're going to do, in my opinion, or my recommendation, is to get the velocity, because speed is the absolute value of velocity. And we'll do that just by taking the derivative. And this is a pretty quick power rule, so let's just jot that down. This is going to be 6t squared minus 54t plus 84. So that's the velocity. Now, if you were to graph this, it's going to go above and below the x-axis. But we're interested in where the speed is decreasing, not the velocity. So I'm going to show you a picture of the velocity graph for t is greater than 0. And it looks like the farthest I need to go is 7 on my x-axis. So I'll show that velocity graph, but we have to be careful how we answer this question. So you can see here I've added a picture of the velocity graph, and notice there's a time when it goes below the x-axis. And so remember that the speed graph would then go like this instead of this piece here. And then our job is to figure out where the speed is decreasing. And so remember, decreasing is where it has a negative slope. So that would be this section here and this section here. Now we need to find those points so I know which choice to choose. And so I'm going to do that using my functions under my Calc menu on my graphing calculator. So the first thing I did is I used my minimum to locate this point here, which is really this point on the speed graph. And that came out to be 4.5, which is 9 over 2. So just keep that in mind, that this point here, the x-coordinate is 9 over 2. Okay, now I also need to locate these zeros. So I'm going to use the 0 feature on the graphing calculator to locate the other 2 points so I can choose my answer. And when I did that, the left-hand point over here, that was x equals 2. And the right-hand point over here was 7. And so now these green intervals that I've drawn on the picture, one of them is 0 less than t less than 2, and the other one is 9 over 2 less than t less than 7. And so that would be choice C in terms of our answers, and that is the correct choice. Now that I've seen myself do this, I probably could have made that picture quite a bit bigger. Hopefully you can see this in the video. But we use the graphing calculator to help us figure out what these intervals are. Now, the other thing I'm going to show you real quick, you can actually graph the absolute value of this. If you take the function and just insert the ABS, which is under the math button, you put ABS around this guy, right? See how fancy that is? And it'll graph the correct function. Let me take a quick picture and show you what that looks like, just so you can see that we found the right spots. So when I insert ABS around my function, like this, and that's located under math, and then num, and then it's 1, I get the graph that we drew on the last picture, and then you can clearly see that we did have those decreasing intervals written correctly. Okay, so hopefully this helps you with these 3 problems. These are 3 problems that we had some trouble with. But as we practice, we'll get better at interpreting these things. In the meantime, if you have any questions, you know where to find me. Take care.